Hello everyone, and welcome to my video. I will walk through the steps I took to improve the performance of my classifier, as well as the techniques I use to assess and enhance its feats. So very first step is data processing and feature engineering. One of the most crucial steps in improving classifier performance is data pre-processing. So first I handle the missing values by using imputation techniques, and I applied the feature scaling using standardization, which ensures that the features which different ranges do not dominate the model's leading process. Next, I focused on feature engineering. I examined the correlation between features and removed those who were highly redundant. I also created new features based on domain knowledge. Next step is the handling class imbalance. If the dataset is imbalanced, meaning one class was significantly under represented, I use mode synesthetic monitoring over sampling technique, generate synesthetic samples for the mandatory class. This helped prevent the models from being biased towards the majority class. In some cases, I also tried under sampling the majority class to maintaining a balanced dataset. Next step is the selecting the optimization of the right models. So instead of relying on the single classifier, I experimented multiple models such as random forest, XGBoost, LightGBM, and logic regressions using Peccarrot. I compared their baseline performance and chose the best performing one. So to further improve my chosen classifier, I perform the hyperparameter tunings using grid search CV and the randomized search CV. These techniques allow me to systematically test different combination of parameters to find the optimal configurations. I also use the stratified k-fold cross validations to ensure my model was evaluated consistently across different subsets of the data. The next step I use to evaluated the model fits to assess how well my classifier fit the data. I looked at several evaluation metrics beyond just accuracy. This include precision and recalls, F1 scores, ROC, and AOC scores. I also analyzed the confusion metrics to see how the models was making errors and helps identify if the models were struggling with false positive or false negative. The next step is addressing overfitting and underfittings to improve the model's generalizations. I address overfittings by implementing techniques like regularizations, job outs, and pruning. Additionally, I reduce complexity by limiting tree deaths in decision trees and adding penalties for large coefficient in logistic regulation. For underfitting, I ensure that my model had a sufficient complexity by adjusting hyperparameters, increasing the number of features, and sometimes trying more sophisticated models. Next step is feature importance and interpretability. So to understand why the model is making certain predictions keys to improve my performance, I use feature importance scores from tree-based models like XGBoost and Random Forest, identify which features had the most impact. And if the features wasn't contributing much, I consider removing and reduce the noise in the data. So for conclusions, all in all, improving classifier performance is a iterative process that involving pre-processing, balancing data, selecting the right models, and tuning hyperparameters, and also evaluating fits and avoiding overfitting and underfittings. So by applying all of those strategies, I was able to significantly enhance my model's accuracy and reliability.